This is Himabindu from the Department of CSIT, Assistant Professor in IARE College. So today in this video, I would like to explain about the normal forms. So normal forms in CFG, context-free grammar. So what is mean by normal form and what is mean by context-free grammars, we will discuss in this video. So why we go for the normal form? So we have grammars like regular grammars, context-free grammars, and Turing machines with the unrestricted grammars. So these are all the grammars we have. So coming to the grammar definition, we also have the grammar with the four tuple notation. V is nothing but non-terminals, and T is nothing but terminals, and S is nothing but the start symbol and start state, and P is nothing but production rules. So this is the general abbreviation for the formal grammar. So here whatever the grammar is there, we have to define like this. So how many non-terminals are there, how many terminals are there, and S is for start symbol and P is for production rule. Based on the production rules, we can differentiate the grammars. Suppose here, if it is a left hand side only single value, and right hand side it is having the multiple values with the A, B, and here it is a small a's are representing. So here let me write V is nothing but it is a capital letter. V is a non-terminal with the representation capital letters. So and T is nothing but T is equal to terminals. So which are represented with the small letters. So here right hand side it is a combination of terminals and non-terminals. So terminal and non-terminals. So here based on the rules like it is a combination of terminals and non-terminals, and left hand side only a single length. So these are all the conditions we can differentiate the based on the production rules. So some grammars are like two length here in the left hand side, and right hand side only single value, and also we have this is the two length, and here we have the three length like this. So these are all the different type. This is one grammar, and this type of grammars are one type, and these grammars are one type. So like this we can differentiate based on the production rules in the grammar. So this is all about the grammars. And now why we go for the normal forms? So by reducing the grammar. So what is meant by reduction? So reduction or minimization in the grammar. So coming to the context-free grammars, we are going to minimize the context-free grammar with the three things. One is useless symbols removal. And second one is eliminate epsilon production. And eliminate, and the third one is unit production. We need to remove. We need to do all these steps while minimizing or reducing the grammar in the context-free grammar. So here by reducing the grammar gets minimized but does not get standardized. So here by performing all these operations, we can say that the grammar is minimized, but it is not a standardized way. To maintain that standardization, we are going for the normal forms. So here we are going for the normal forms. So this is because the RHS. So RHS is nothing but right hand side of production have no specific format. So here, while coming to the context-free grammars, we have this kind of production rules. So left hand side only one non-terminal, and right hand side it is a combination of terminal and non-terminal combination. So here right hand side of we are talking about the context-free grammars. So right hand side we have the no specific format is there after minimization. So in order to standardize the grammar, normalization is performed using the normal forms. So how we are going to normalize, in the sense, by using the normal forms, we can maintain the standards, we can maintain the grammar with the standards. So we require only right hand side. Obviously left hand side only single value is there, so no need to bother about that one. So we have only right hand side, it is a combination of terminal and non-terminal. So that's why we need to maintain some standards in the right hand side. We are going for the normal form. So to maintain the standardization in the grammar, we need to perform the normal forms. And if you want the grammar in specific format, so here we have some specifics. There should be some fixed number of variables and terminals in the context free grammar. To maintain the standards, we require the normal forms. So how we will design these normal forms, in the sense, we are going to divide the values like this many number of values should be there in the left hand side, and that is also, it's a combination of terminal or non-terminal, like that we need to maintain some constraints in the normal forms. So here we have two types of normal forms. One is Chomsky normal form and second one is the Grayback normal form. So here we'll talk about this CNF. We can simplify it as a CNF, Chomsky normal form, and second one is a Grayback normal form. So these are the two normal forms we are going to maintain the standardization or normalization in the context-free grammars. So coming to the CNF, Chomsky normal form. So what is this representation? Chomsky normal form is a CNF. We can we can write it as a CNF. And a context-free grammar is a, of all the production rules, satisfy one of the following conditions. So to maintain the CNF, the grammar in the CNF, we have some conditions. What are those? We will see. The start symbol generating epsilon. So in case the start symbol, so suppose here we will write SA and epsilon. So for example, A tends to epsilon, and we have conditions like this, and a non-terminal generating two non-terminals. So for example, A tends to AB. So here the production rules are always like this only. Either it is a combination of, as epsilon is also acceptable, AB is two non-terminals is acceptable, and single terminal is also acceptable. So these are the three conditions we need to follow for the CNF, Chomsky normal form. And generating a terminal, so S tends to A. And here are the two grammars. In this one, we will check whether these three conditions, either epsilon, two non-terminals and single terminal is there or not. Then only we can say that if the grammar contains the three values, we can say that it is a the grammar should be in the CNF, Chomsky normal form. So S tends to AB. So this grammar is there. This production belongs to the CNF, and S tends to small c, that is a terminal, so this is also acceptable, and A tends to A, small a, this is also acceptable, and A tends to B, it is also acceptable. So these two conditions are satisfied here. Coming to the grammar 2, in this one, so terminal followed by non-terminal. So this is not our condition, so the only two non-terminals is accepted here. So that this production rule is not belongs to the CNF, and these two are belongs to the CNF. So if the grammar is not satisfying the conditions, three conditions, we can say that it is not a CNF. The grammar is not having the CNF normal form. And how we are going to convert the given context-free grammar into a CNF, Chomsky normal form. So here step 1, eliminate the start symbol from the RHS. So here we need to remove the start symbol from the RHS. If the start symbol T, so start symbol here I am observing as a T, is at the right hand side of any production. if the start symbol T is there, suppose here T is the start symbol, then it is having, so A, B tends to B, T, B. So like this, if the string is, the start symbol is there of any production rule, it is having the right hand side is there, we need to include S1 tends to S. We need to write like this. This is the first step. And second step, in the grammar, if there is any minimization steps are there, like removing the useless symbols and epsilon productions, removing the epsilon productions, and unit production, removing the unit productions. We need to perform the minimization. So this step 2 belongs to the minimization. So, and step 3, so eliminate the terminals from the RHS of the production. So here, if they exist with the other non-terminals or terminals, for example, the production with the A tends AA, we need to write the value like here OR is included and OR is going to be terminal. Here OR belongs to the terminal. Like this, we need to write for the conversion of CNF to CFG to CNF. And step 4 is eliminate RHS with more than 2 non-terminals. So here more than 2 terminals are there. Suppose S tends to A, B, B like this. So we need to give 2 values like C tends to AB, and then we'll write S as a CB. So that these 2 conditions, this one is 2 non-terminals and this one is also having the 2 non-terminals, so that the condition of CNF is accepted here. So these are the steps we need to follow for the conversion of CFG to CNF, Chomsky normal form. And next, Grayback normal form. So what is meant by Grayback normal form? So Grayback normal form is a context-free grammar is in C and G and F if all the production rules satisfy one of the following conditions. So the start symbol generating epsilon is also accepted, and single terminal value is also accepted. And the third condition is the terminal which is followed by n number of so terminal which is followed by n number of non-terminals. So these are the 3 conditions we need to follow for the GNF, Grayback normal form. So first one is this epsilon is also accepted, and A tends to terminal is also accepted, and the symbol which is going to be right hand side, the terminal followed by n number of non-terminals or V. We can write it as non-terminals, so we'll represent with the V. So this is the example. We need to tell whether it is whether the grammar is in GNF or not, we will check. So here terminal followed by 2 number of non-terminals, so this is accepted, and terminal which is followed by 1 non-terminals. So here what it says, the terminal, so A is followed by either single or double or triple, how many are there, we need to accept as a G and F. So suppose here only AB is there, so this is also acceptable. So here 2 A or B is there, this is also acceptable, and here also only single value is there, we need to accept, and here also single, and this one terminal is also accepted. So these are all going to be in the G and F, Grayback normal form. So these are the conditions we need to follow for the G and F, Grayback normal forms. and how to convert the given GNF into a given CFG into a GNF. So the input is context-free grammar, and then we need to convert it to a GNF, grayback normal form. So here check if the given CFG has any input production. So first step what we have to do, we need to check for the minimization step. So if the grammar is given, we need to check whether the minimization given performed or not. So suppose here it is having epsilon symbols or unit productions or like useless symbols are there, we need to remove all the things, and then we need to move to the second step. So the second step what it says, check whether the CFG is already in CNF and convert it to a CNF. So here whether it is already in CNF or there, we need to check. So if the grammar is given, we need to check whether it is it is in CNF or not. We need to check. It is not there. We need to first convert it to a CNF. Then we need to go to the next step. So this is the second step. And third one, change the name of non-terminal symbols. So here non-terminal symbols into some A in ascending order of AI. So this is the example. So here if you observe this, every production rule is in CNF. So first step and second step is already done. So here in this CA, so all are only two non-terminals on single terminal is there. So this is already in CNF. And next third step what we have to do, we need to do, suppose here S is their start symbol, so S I will assign it as a A1 and C assign it as a A2 and A assign it as a A3 and B assign it as a A4. So like this we need to change the names of non-terminals values, and then next we need to check. So here suppose A1 is equal to A4 like this. So this is the I value and this is the J value. We need to check for the two conditions. So alter the rules so that non-terminals are in ascending order. So we already done. So A1, A2 like that, such that if the production rules is of the form AI tends to AJX, then we need to follow the conditions A less than or less than J or I greater than or equal to J. So these are the two conditions. So in this one, if less than is there, we need to simply leave like that. Leave the production as it is. And in case of these two conditions, I greater than J and I is equal to J. So this equal to represent left recursion. So I greater than J. So in this kind of situation, so I greater than J, we need to replace the values. So here the values of J we need to replace the values with substitution method. So in this one we can change all the grammar into a GNF, grayback normal form. And third step is, in case of any left recursion is there, we need to remove that left recursion. So how to remove that left recursion we will discuss with the example. And introduce new variable to move the left recursion. So how we will perform this left recursion? We will introduce one new symbol into the production, then we will remove the left recursion. So these are the steps to follow for the context-free grammar into a grayback normal form. And here is the example. So convert it to a GNF. So here GNF, and then we will convert the So here G and F. So we already saw the C and F, how to change. So let me write first CFG, CFG to C and F. Suppose here S is a start symbol and A is there, and unit production. Suppose here unit production is there, and B, A tends to terminal and B tends to capital small b. So if it is a CFG, so this is a CFG, then first step to convert it to a C and F, we need to minimize this one. So minimize. So minimization, we have no epsilon there, epsilon is not there, and unit production is there. So unit production we need to remove in this grammar. So how we will remove this unit production? A and B we are going to substitute with the value. So here, and by after seeing this one, we have the grammar with the minimization. So then we will convert it to a grammar called CNF, Chomsky normal form. So here already A tends to small a is there. So then I will write, instead of this small a, so I require non-terminal. So non-terminal is required, so that it is A tends to capital A tends to small a. I will write it as A and capital A and B. So only here only we need to change. Why? Because these terminals are always accepted here. And here, so remaining all are A tends to capital A tends to A and B tends to B. So by seeing this one, we can say that it is a C and F. So this is the example of converting the context-free grammar into a Chomsky normal form. And now we will see a Chomsky normal form into a Grayback normal form. So why I am saying it as already in C and F? If you see this grammar, so first productions is having S tends to. These are the two non-terminals, and this is also two non-terminals. So it is coming to the C and F. And terminal is also, all terminals are also C and F. And these two also C and F. So if we see this grammar, we can say that the grammar is in C and F. And this is the second step. So first two steps are finished, and then third step is we need to assign the values, or we need to change the values of the non-terminals in a ascending order. How we will see? Third step onwards, step 3. So here S is equal to A1. So I'll write it as equal, and C is equal to ascending order. So here first, second, third, like that. So C is equal to A2, and A is equal to A3, and B is equal to A4. So we just assign the values with A power AI. And now we will write it with this production, with these names. So S is nothing but A1 is equal, A1 tends to, C is equal to A2, A3, and BB is equal to A4, A4. And we will write all the production rules with this only. B is nothing but here A4, and terminals we don't need to change. And S is equal to A1, and here B is there. B in the sense we need to write A4. And here again we have the C. C is nothing but here A2, and B is there, and here A is equal to A3 and A. So we'll leave these two things. Why? Because they are already in the terminals, so no need to change the values. And here we will check from the two production rules. A1 tends to A2. So A2, A3, A4, A4. So here there are two conditions. I less than or equal to j, we need to replace. So I less than j, we need to leave like that only. So here I is equal to this one and j is equal to this one. So we need to check for two productions. So that I will write it as A1 tends to A2, A3 one time and A1 tends to A4 one time. So here A1 tends to I less than j. So these two conditions are satisfied. So I less than j. So I will write it as A1 tends to A2, A3. So I am not going to change these values for now. And next we need to go for the second production rule, that is A4. So A4 tends to be A1, A4. So here A1, A4 is there. So here I greater than or equal to greater than j is there. So what we have to do? We need to replace it with A4 and A4 tends to, so A4 tends to B. So here A1 is there. So in this one A1 value is already there. So we need to replace this value. So A1 is this one, A2, A3. So A2, A3 and along with the A4. So for this production rule also A4, A4 and this A4. So we are just, instead of A1, we are writing these two production rules with the substitution method. And now we need to check. So A1 is already checked. So there is no replacement. And then we need to check for the A4 also. For every production rule, we'll need to check. So here also A4, 4 is greater than 2. So we need to change this A2 also. How we will change? So we will just substitute A2 value. So A2 tends to B. So here A4, B, B and A3, A4. So remaining A4 we have to write like that only. So here this one is also, so if you observe B is a terminal, so which is accepted by the GNF. So conditions, so terminal S tends to terminal and S tends to A or B, and second condition is the terminal followed by n number of non-terminal is also accepted. And here we need to check A4 is there. So here I equal to j is there. What we say? It is the left recursion. So how to remove this left recursion we will see. So in this one we will write the values. So we need to write one formula to remove the left recursion from the grammar. So here A tends to, suppose here A tends to A. So these two values are same, two non-terminals, and followed by the alpha and beta is there. We need to write the formula like A tends to, so alpha A dash, beta A dash, and next A1 tends to alpha A1 slash epsilon. So we need to write these two steps to remove the epsilon production. So here assume that here we need to analyze the values in this formula. So here A is nothing, A is equal to, coming to this production, A4 is there, A4 is there. So for which production we need to check, in the sense A4, triple A4. So 4 is there. So that's why I is equal to J. So here A4 is equal to A and alpha is equal to, so it's a combination A4 alpha. So A4 and beta. So beta is nothing but these are all the beta. Beta is equal to B slash A3 A4. So this is the beta. So according to that one, we need to change the values. So here we will write it as a, so A tends to, so that is nothing but, so this is step. So from this here we need to write, so A4 tends to, so beta is nothing but this one. So B, A3, A4 and A1. So what is this A1 in the sense? We will just add new variable, we'll write it as, instead of A1 to easily, we'll write it as a Z. So Z, and this Z is equal to, so Z is equal to alpha. So what is meant by alpha? A4 and Z epsilon. So epsilon. So this one is changed to, so epsilon we need to remove. So that is nothing but minimization. So how to remove this one? We will just replace this Z with the epsilon, and whatever the result we will just add to that production rule. So A4 Z, and instead of this epsilon we are going to substitute the value A4. So these are the two production rules. So here A4 is there. And here after this one we need to check whether all the values are in production, all the values are in GNF or not, we need to check. So if you observe this, A is the A4, so terminal is accepted and non-terminal is also accepted here. And coming to this one, we have to change this A4 value. So how we need to change these two A4 values, we will see. So Z tends to A4. So instead of this A4, how to change these two values in the sense, we need to just substitute the values. So substitute of this A4. So A4 value is equal to, so B A4 one time. So B A4Z and B A3 A4, B A3 A4 Z with A4Z. And next A4. So A4, instead of this A4, we will write it as a B A4 and B A3 A4 Z A4. So here we all have the grammar like A4 B. So terminal which is followed by n number of non-terminals. So this is also non-terminals, n number of non-terminals, and this is also non-terminals. So let me write all together. So all the productions I will write it here, and so here, so first one is A1 tends to. So A1 tends to we haven't changed. So but the production rules which is terminals, we need to terminals which is followed by the non-terminals. So here I will just substituting this A1 production with the A2 is there. So instead of A2 is equal to B and A3 is equal to, so A3 is equal to A. So we need to substitute these two values. So only first terminal we need to replace. So A2 is equal to, already B is there. So B A3. And here A4 is there. So A4 we already have this value. So that I will write it as a, so B A4 and B A3 A4 Z A4. So this is all the A1 production rule which is all having all passing this GNF condition. So B A3 and B, all the terminals which are followed by the n number of non-terminals. This is first production. And coming to the second production, so B is nothing but A4. So A4 tends to B A3 A4 Z. And next this third one, So third one is Z we need to replace. Why? Because we introduced the new terminal. So Z we need to write. Z tends to be A4Z and B A3 A4Z A4Z and B A4 and B A3 A4 Z A4. And coming to the values A2 and A3. So this is B and this is A. So if you observe all together the grammar after minimization and after converting GNF, the CFG into a GNF, these are the production rules. So here we can check whether the conditions is satisfying of GNF is satisfying or not. B is followed by a terminal which is followed by n number of non-terminals. Here also this one and this one all together they are satisfying the conditions of G and F. So like this we need to change, we can convert the given context free grammar into a grayback normal form. So these are all about the normal forms, and these are the references. We have taken the examples, and so we have two types of grammars. One is two types of normal forms. One is the Chomsky normal form and grayback normal form. In this one, after minimization, we need to perform this normalization. So in the coming to the CNF, we need to maintain the S tends to terminal, and terminal S tends to not S, any non-terminal which is having in the grammar, and this is a combination of two non-terminals like this, and these two production rules for the C and F. And coming to the G and F, S tends to A is accepted and S tends to A and number of non-terminals, so A, B, C, like that we can write, and these two are the conditions we need to remember for the G and F. So these are all about the normal forms. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.